Imagine a thermostat. Now imagine that thermostat controlling the climate of an entire planet. That's the role Antarctic ice plays in our world. Welcome to the vast expanse of the Antarctic, a place often misconstrued as just a barren, icy wilderness. But in reality, it's a dynamic and integral part of the Earth's climate system. Its importance, immeasurable. It's not just the Earth's freezer, it's also the Earth's mirror, reflecting sunlight back into space. This is the albedo effect, a crucial phenomenon that helps regulate our planet's temperature. The Antarctic ice, with its brilliant white surface, acts as the Earth's natural sunscreen. It reflects a significant amount of the sun's heat back into space, preventing it from warming the Earth too much. This reflective property of ice and snow is termed albedo, which simply means whiteness. The higher the albedo, the more sunlight is reflected and less is absorbed. Antarctic ice has one of the highest albedo ratings on Earth, reflecting about 80% of the sunlight that hits it. This means only a small fraction of solar radiation is absorbed, keeping our planet cooler. It's a natural cooling system, if you will. But here's the catch. The albedo effect is a delicate balancing act. As the Earth's temperature rises and Antarctic ice melts, less sunlight gets reflected back into space. More is absorbed by the darker ocean and land surfaces, which in turn heats the Earth even more. It's a feedback loop, one that could have serious implications for our global climate. So, as you can see, Antarctic ice isn't just a frozen wasteland. It's a crucial part of our climate system, a vast icy thermostat that plays a vital role in regulating the Earth's temperature. And as we journey further into the heart of this icy wilderness, we'll uncover more of its secrets and discover why it's so critical to our planet's future. Now let's follow the life of an ice core, from extraction to lab analysis. Imagine an icy landscape stretching as far as your eye can see. Amidst this frozen wilderness, a team of scientists set up their drilling equipment. Their mission? To extract an ice core, a cylindrical sample of ice extending deep into the ice sheet. This is no easy task. It requires precision, patience, and a lot of warm clothing. The drill bites into the ice, spiraling downwards, layer by layer. Each layer corresponds to a different year, much like the rings in the trunk of a tree. The deeper the drill goes, the further back in time it travels. Some cores even reach back hundreds of thousands of years. Once the core is extracted, it's carefully packed and transported to a laboratory. Here, the real detective work begins. The ice core you see is a time capsule of Earth's atmospheric history. How so? Well, as snow falls and accumulates over centuries, it traps tiny bubbles of air. These bubbles, perfectly preserved in the ice, contain samples of the atmosphere at the time they were trapped. By analyzing these bubbles, scientists can determine the levels of various greenhouse gases, such as carbon dioxide and methane, present in the atmosphere at different points in history. But that's not all. Other elements trapped in the ice, like dust and volcanic ash, can provide clues about global events that occurred in the past. A layer rich in volcanic ash, for instance, might indicate a major volcanic eruption. This information is invaluable. It helps us understand how our climate has changed over time and how human activities have influenced these changes. By studying ice cores, we can gain insights into the Earth's past, which in turn can help us predict and prepare for the future. In essence, the journey of an ice core is a journey through time, a journey that can teach us a lot about our planet and our impact upon it. So each ice core is like a history book, telling us the story of our planet's climate. Glaciers may seem static, but they're constantly moving, shaping the landscape in their slow-motion journey. These icy rivers, some as old as the last ice age, are constantly in motion, driven by the inexorable pull of gravity. They inch forward day by day, year by year, carving out valleys, scouring mountainsides, and quite literally shaping our world. As glaciers move, they create distinct features that are as beautiful as they are fascinating. Picture this: deep fractures splintering the glacier's surface, forming crevasses, some reaching depths of several hundred feet. These spectacular chasms are not just random cracks. They're the result of the glacier's movement over uneven terrain, a testament to the immense power and weight of the ice. Now, imagine towering shards of ice jutting up from the glacier's surface. These are seracs, another unique feature formed by the glacier's movement. They appear when two crevasses intersect, creating a landscape that's as dramatic as it is dangerous. Then there are moulins, vertical shafts that bore into the glacier, sometimes reaching all the way to its base. Formed by the meltwater on the glacier's surface, these moulins are like nature's plumbing system, channeling water through the glacier and out at its terminus. But glaciers aren't just about ice and cold, they are also about life. In the wake of their slow progression, they leave behind a trail of rich, fertile soil, a gift from the glacier to the life that follows. The movement of glaciers is a dance that takes place over centuries, a ballet on a geological scale. And just like a dance, it leaves behind a pattern, a record of the glacier's journey. These patterns tell a story of climate, of change, and of the Earth's history. These icy behemoths are not just beautiful, they're an integral part of our planet's topography. They shape our world, literally and figuratively, and remind us of the power and majesty of nature. So, the next time you see a glacier, remember you're not just looking at a chunk of ice. You're witnessing a dynamic living process, one that's been shaping our planet for millions of years. Our planet is heating up, and this is having a profound impact on Antarctic ice. Now let's delve into the current research on how climate change is altering the icy landscapes of Antarctica. Our blue planet is getting warmer, and the effects are all too apparent in the icy wilderness of Antarctica. The Antarctic Peninsula, one of the most rapidly warming areas on Earth, has warmed by nearly 3 degrees Celsius in the last half-century. This warming trend is causing dramatic changes in the Antarctic ice. The Antarctic ice sheet, the largest single mass of ice on Earth, is shrinking. The loss of ice from Antarctica has increased sixfold since the late 1970s, causing sea levels worldwide to rise. This is not a gradual, centuries-in-the-future problem. This is happening right now, in our lifetime. But it's not just the melting ice that's a concern. The process of calving, where huge chunks of ice break off from glaciers and float out to sea, is becoming more frequent and more dramatic. These calving events can lead to huge, sudden losses of ice. In some cases, glaciers are losing more ice through calving than they are through melting. The loss of Antarctic ice isn't just a problem for the creatures that call Antarctica home. It's a problem for all of us. You see, the Antarctic ice plays a crucial role in regulating the Earth's temperature. The ice reflects sunlight back into space, helping to keep our planet cool. But as the ice melts, less sunlight gets reflected, and more gets absorbed by the ocean. This warms the ocean, which in turn leads to more ice melt in a vicious cycle. The rapid changes happening in Antarctica serve as a stark reminder of the urgent need to address climate change. The loss of ice from Antarctica affects us all, contributing to rising sea levels and disrupting weather patterns around the world. Climate change isn't just a future problem. It's happening now, and it's changing the face of Antarctica. What does the future hold for Antarctic ice? Let's delve into the predictions. As we gaze into the crystal ball of science, we see a range of potential scenarios for Antarctic ice, all hinging on our global actions against climate change. Some predictions paint a sobering picture, suggesting that if greenhouse gas emissions continue unabated, we could witness a significant reduction in the Antarctic ice mass, with profound implications for sea level rise and global climate patterns. Other scenarios, however, offer a glimmer of hope. If we can achieve a substantial reduction in emissions, the loss of Antarctic ice could be slowed or even halted. This would buy us time to adapt and innovate, to further understand the intricate dance between Earth's climate and its polar ice caps. But these scenarios are not set in stone. They're based on our current understanding of Antarctic ice and its response to climate change, an understanding that is still evolving. That's why ongoing research and monitoring are so critical. It's through the meticulous work of scientists, drilling ice cores, tracking glaciers, analyzing data, that we refine our predictions and, in turn, our response to climate change. We're not just passive observers in this story. We're active participants with the power to shape the future of Antarctic ice. Every action we take, every policy we implement, every bit of research we conduct can tip the scales in favor of a more sustainable future. Just as the Antarctic ice shapes our world, we shape its future. It's a responsibility we cannot afford to ignore. We must continue to learn, to adapt, to mitigate. To do otherwise would be to turn our backs on the future, to ignore the lessons of the past etched so clearly in the ice. The future of Antarctic ice is uncertain, but one thing is clear. We need to keep watching, keep studying, and keep caring. We've taken a journey through the life of Antarctic ice. Now it's time to take stock of its global significance. Antarctic ice holds a critical role in the grand scheme of our planet's climate systems. To start, let's consider its influence on sea levels. The Antarctic ice sheet is the largest single mass of ice on Earth, containing about 90% of all the fresh water on the planet. If all this ice were to melt, sea levels would rise by about 200 feet. That's equivalent to submerging a 20-story building underwater. This potential for drastic sea level rise underscores the importance of preserving the Antarctic ice sheet. But the role of Antarctic ice extends beyond sea levels. It's also a powerful climate regulator. One way it does this is through the albedo effect. The Antarctic ice reflects a substantial amount of the sun's rays back into space, helping to maintain our planet's temperature. Without this reflective surface, more of the sun's heat would be absorbed by the Earth, leading to accelerated global warming. Antarctic ice also drives the thermohaline circulation, a global conveyor belt of ocean currents. Cold, salty water from the Antarctic sinks to the ocean floor, setting off a chain of currents that circulate warm and cold water around the globe. This process plays a vital role in distributing heat and regulating the Earth's climate. And let's not forget that ice cores extracted from the Antarctic provide invaluable climate data, offering a glance into the Earth's atmospheric history. These frozen time capsules help scientists understand past climate events and make predictions about future climate scenarios. In short, Antarctic ice is a vital component of Earth's climate machinery. It's a gatekeeper of sea levels, a reflector of sunlight, a driver of ocean currents, and a historian of our planet's climate. Antarctic ice is more than just a frozen desert. It's a key player in the health of our planet. It's our responsibility to protect and preserve this icy wonder for the sake of our future and the health of our planet. Now that we understand the importance of Antarctic ice, what can we do to protect it? The answer lies not only in the hands of scientists and researchers, but in every one of us. We can all play a part in safeguarding this icy marvel, and in turn, our planet's climate. One of the most potent ways to do this is by supporting climate research. Knowledge is power, after all. By funding scientific endeavors that explore the intricacies of our climate, we enable a deeper understanding of the processes at play, paving the way for more informed decisions and strategies to combat climate change. Environmental conservation is another critical aspect. This involves everything from minimizing our carbon footprint to advocating for policies that protect our natural resources. Remember, small changes in our daily habits can have a significant impact on a larger scale. Consider adopting more sustainable practices in your life, like reducing waste, conserving water, or using renewable energy sources. And let's not forget the power of education. Sharing the knowledge we've gained about Antarctic ice and its role in our climate systems can create a ripple effect, inspiring others to take action as well. Encourage conversations about climate change in your communities, schools, and workplaces. Let's make this a topic that's not just discussed in science labs, but in living rooms and classrooms across the globe. Finally, remember that every action counts. Whether it's donating to a climate research foundation, planting a tree, or simply turning off the lights when you leave a room, every effort contributes to the larger goal of protecting our planet. And it's not just about preserving Antarctic ice. It's about securing a sustainable future for ourselves, for the diverse species that share this Earth with us, and for the generations yet to come. In the end, the fate of Antarctic ice is in our hands. The question is, what will we do with this responsibility?